Hey, what is going on? This is Mr. Bainey, and the lesson here is 4.1, representing linear non-proportional relationships. The standard is 8.f.3 in the top right, and the essential question is, how can you use tables, graphs, and equations to represent linear non-proportional situations? So this lesson is a continuation of what you learned from Module 3, which is all about proportional relationships, and that the general form was y equals kx. We could do y divided by x to find our constant and proportionality, and that represented our slope and things like that. So you're going to see some of the same terminology as we go into Module 4. But what we're going to do in this one is to work a lot with table of values. So our first example that you see here is, let's do the your turn. Francisco makes $12 per hour doing part-time work on Saturdays. He spends $4 on transportation to and from work. And it gives us the equation y equals 12x minus 4, and that gives his earnings y. So see if this makes sense. He makes $12 per hour, so it's 12 times the number of hours. And then he's going to subtract $4 because he's spending $4 just to get to and from work. So he could be taking the bus or something like that. So we want to make a table of values for this situation. And so we're going to be using the equation to figure out how much he's actually going to earn. So if the number of hours is 0, for example, then we're going to take the equation y equals 12x minus 4. And for if x is 0, then it becomes y equals 12 times 0 minus 4. So 12 times 0 is 0, and 0 minus 4 is -4. So this actually doesn't really make any sense. It's saying that he's actually going to work, not working any hours at all. So he has to spend $4 and then comes back from wherever he works. So he actually doesn't make any money at all. He loses $4. That's what that means. So what if he works 1 hour? Then it would look like this. Y equals 12 times 1, then minus 4. So 12 times 1 is 12, and 12 minus 4 is $8. So if he just goes to work and only works for 1 hour, then he goes back home, he's making a total of $8. So he makes it $12 for that 1 hour, then has to spend $4 for the transportation. 2 hours, I'm going to do it off to the right side here, is going to become y equals 12 times 2, then minus 4. So 12 times 2 is $24, and 24 minus 4 is 20. So it makes $20 there. And finally, for 3 hours, y equals 12 times 3 minus 4 equals 12 times 3 is 36, and 36 minus 4 is 32. So that is our table of values. Notice that I just chose the x values and then plug them in to figure out how much money Francisco would earn. You can choose whatever x values you want. You'll probably want to stick to ones that make sense or that are easy to plug in. So I stuck with just small numbers, starting with 0, 1, 2, and 3. You could have done something like 5 hours, 10 hours, 20 hours, so on. Okay, on the next page, let's take a look at this Explore. The entrance fee for Mountain World theme park is $20. Visitors purchase additional $2 tickets for rides, games, and food. So the equation y equals 2x plus 20, I'll box that, gives a total cost, y, to visit the park, including purchasing x tickets. So the number of tickets, x, so if the visitor only purchases 1 ticket, it's going to be $20 to get in and then $2 for 1 ticket. So that'd be $22 total. But if somebody wants to buy, let's say 10 tickets, then 10 tickets would mean that's $20, and then there's also $20 to get in. So this equation is going to give us the total cost. including those tickets that are purchased. So let's complete the table of values. I want to be showing some work off to the side. So if the visitor purchases 0 tickets, then hopefully the $20 makes sense. So no tickets means the person's only paying to get into the theme park, and that's it. So what about $2? Sorry, not $2, 2 tickets. 2 tickets means that we're taking $2 per ticket times 2 tickets, and then we're adding 20. So that means $4 for the 2 tickets plus 20 would be 24. Okay. And then 4 tickets would mean $2 per ticket. There's 4 tickets plus 20. So 2 times 4, that would be $8 for the tickets, plus 20 would be 28. And then 6 tickets would mean $2 per ticket times 6 tickets, then plus 20. 2 times 6 is 12. That's $12 for the tickets, plus 20 is 32. And then lastly, for 8 tickets, we get 2 times 8 plus 20, which is going to give us a total of 36, if I work that all out. So I'm going to plot the ordered pairs using the table of values. So I'm going to highlight what I'm actually supposed to be graphing. So for 0 tickets, it's 20 bucks. So that's 1 point. I'm going to just graph that right now. So 0, 20 is actually right about here. It looks like this graph on the right side goes by 4s. Then my next one is going to be 2, 24, right? 2 tickets means there's a total cost of $24. So it's going to be 2 tickets, $24. And then I'm going to go ahead and do the rest without circling what is in the table. So 4, 28. Then we got 6, 32. I'm just naming off the table of values on the top there. And then 8, 36 is our last point. So we want to describe the shape of the graph. So the shape is a straight line, because you can see that it just goes in a straight line. And my line is not very straight, but it's supposed to be a straight line. So we want to find the rate of change between each point and the next, and is the rate constant? So I'm going to end up erasing some of this up here at the top. And we're going to look at rate of change. Remember that rate of change is change in y divided by change in x. And we're going to look at change in y. So how much does the cost change? It changes by 4. The number of tickets here changes by 2. Okay, so the rate of change is 4, change in y, divided by change in x. That's equal to 2. So what about from 24 to 28? That changes by 4. And from 2 tickets to 4 tickets, that changes by 2. From 28 to 32 changes by 4. From 4 tickets to 6 tickets changes by 2. And then from 32 to 36 changes by 4. And you get the idea here. So what this means is that the total cost is going up $4 when you buy 2 extra tickets. So it's how much the cost is changing when we change the number of tickets. Okay, so it is constant. So it's always 2. We're going to say it is a constant rate. And I've shown it from the arrows that I've drawn in the table above. Step number 4, we're going to calculate the rates of change for the values in the table. Explain why the relationship between number of tickets and total cost is not proportional. So I've already calculated rate of change. So rate of change is always 4 divided by 2. That's always like that in the table, which gives us a 2. And the rate of change, or it also could be unit rate, it's actually $2 per ticket. And this that I just wrote, check this out. It's actually right, look, check this out on the left side, $2 for rides, games, and food, $2 tickets. So it means the same thing. Then why is this not proportional? So there is couple of ways to describe this. Remember that proportional means that I can take y divided by x, and I should always have a constant ratio. So think about this. If you took this y divided by this x, 20 divided by 0, we actually can't do that. We can't divide by 0. But if we did 24 divided by 2, what is that, 12? 28 divided by 4, that's not 12. That actually gives us a different number. So not proportional because 24 divided by 2, I'm going to write y over x, y divided by x. This is not equal to 28 divided by 4. They're not the same. So here we go, we can say not proportional. What might be an easier way to show that it's not proportional is, does this thing go through the origin? So the origin is the point 0, 0. Does the graph touch the origin or go through the origin if it keeps going? And the answer is no, it doesn't. So that's another way to explain it if you want to. And on the next page, it's going to give you a definition of a linear equation up at the top. I am not going to talk too much about that because that's going to show up in the future lessons. Instead, let's go ahead and do the your turn here at the bottom. And take a look at the example if you want to just see some more problems. But we're going to make a table of values, and we're going to graph the table of values on the right side. So we got y equals negative 2x minus 1. So it's actually y equals negative 2 times x plus 1. So if x is negative 1 right here, then it becomes y equals negative 2 times whatever x is plus 1. So that blank that I have there in the parentheses is where I kind of put the input. All of this stuff right here is the inputs. So I want to put negative 1 there. So what's negative 2 times negative 1? That is positive 2. And 2 plus 1 that I have at the end is 3. So when I use negative 1 for x, I get 3 as my answer. So now let's do 0. So what if y equals negative 2 times 0 plus 1? Well, negative 2 times 0 is 0, and 0 plus 1 is 1. Okay? If x is 1, then we'll have y equals negative 2 times 1 plus 1. Negative 2 times 1 is negative 2, and negative 2 plus 1 is negative 1. Okay? Then the last one is x equals 2. So y equals negative 2 times 2 plus 1. Negative 2 times 2 is negative 4. And negative 4 plus 1 is negative 3. And I made a mistake here. That should be a negative 1. So now let's plot this. Remember that I have my points negative 1 comma 3, 0 comma 1, 1 comma negative 1, and 2 comma negative 3. So on the graph, negative 1 comma 3 is up here. 0 comma 1 is here. 1 comma negative 1 and 2 comma negative 3. If you did this correctly, you should notice that it is a straight line. This is a linear equation. Linear means line. And we are done. That's it for this lesson. Thank you so much for watching. I hope it helped you. Have a great day.